It's me, Mr. Todd. I'm back from Singapore. I had a good time. Did a bunch of math with a bunch of other math teachers from China, Indonesia, Singapore. The other ones from Thailand as well. Anyways, we had a good time. Did a lot of math, and it was fun. And I know you guys did not have Miss Ruth for a sub today, and that's because she wasn't feeling well, so she decided not to come in. And I don't know who subbed for you or anything. I haven't really talked to anybody yet. But the reason I'm setting this video is because I wanted you guys to see the solutions for the quiz you wrote today. Because, as you know, you've got your test coming up next class. And yeah, I want to give you some feedback if possible. I know it's not ideal because you may not remember exactly what you wrote on your quiz, but better than nothing. So I did the quiz, took some pictures, and here I'll just show it to you. So obviously this is a video, so if you want to take a closer look at any of these solutions, just pause the video. So I'll just kind of run through them pretty quickly here, making a few comments along the way. These ones I think were pretty straightforward, just applying the formulas for using chain rule and the formulas for exponential logarithmic functions. So there you go, those are all the answers if you want to take another look. Oh, I know what you're going to ask me. You're going to ask, Mr. Todd, what if I didn't put the x cubed in the denominator on my answer? No big deal. If you put the x to the power -3 in the numerator up here, no problem. Still full marks. Don't panic. Okay, let's look at the next. Oh, where am I? There we go. Okay, here's question 7. This one was a product rule question, so there was a function x multiplied by an exponential function here. And so you can see in these big square brackets we had to use the product rule, and there's the answer. Okay, again, you know, if you didn't completely simplify it, depending on how close you got, you may have still gotten full marks. But really this answer I've got here should be the best one. Number 8, implicit differentiation. So it's all good, everything kind of canceled out. You end up with just negative y over x. Okay. Down number 9. Again, nothing too fancy here. This is the one that had a picture of the devil's curve on it, and just had to use implicit differentiation to find the slope at any point, x and y. So there you go. Next page. Okay, what was this one? All right, this one gave you the equation for a circle, and again asked you to differentiate. So once again, this is you need implicit differentiation, and you can see this 2 ends up disappearing on you, so just kind of ends up looking like this. And then the question actually asks, what is the slope of the tangent line at this point? So once you've got the slope function, you need to plug in 2 and 6, and there's the answer, -1/4. Okay, which page is this? 3. Oops. 4, a couple more pages here. Number 11. Here we go. This is the inverse function. So if you did a few practice problems, you got used to this idea of this x is the x on the inverse that's given in the question. So first step was to find what's the x on the original function. And you know, this is weird math here, I realize, but I just kind of assumed, and I'm expecting you guys to be able to figure this one out. So there's no real math. There's no process here. It's just 6 equals 8x cubed minus 2x. And my hope is that you just kind of saw that the answer could be x equals 1. Sorry, it's not very good. I don't know how to teach that exactly, other than just recognize. And you know, you'll see quite a few questions that follow that same kind of pattern. Anyway, I showed you 2 methods. Of course, you only have to do one. I'm looking for the main answer, and that you showed me you knew what you were doing. So that's the answer for 11. Almost done. Number 12. This was an open-ended question, so no, you did not have to write it exactly like I wrote mine. It asks you, like, how do you know when to multiply by that y prime factor when you're doing implicit differentiation? And so, you know, you can pause here, read mine. Basically, you just have to look at the idea, and if you're differentiating with respect to x, and you've got y inside your composition of functions, well then you need to multiply by y prime, because that's using the chain rule. Here's a counterexample. or no, sorry, not a counterexample, but it's another example where you don't need the chain rule. And that's because what you would write here was dx over dx, which is just 1. So that's why there's no y prime in this case. So if you put something like that, you should be fine. Yeah, so I'm looking forward to reading your answers and see what you guys did with those. And the bonus question. This question was only out of 1 mark. And when I go to mark them, I'm really going to expect it to be totally right in order to get that extra bonus mark. Because you can still get full marks on this quiz even if you did not get this one correct. So anyways, it gave you a relationship here, an implicitly defined function. And you're asked if there's a normal line that crosses that relationship at 1, 1, then where's another spot that normal line crosses the same implicitly defined function? Okay, so a few more steps on this one, that's why it's a bonus. And so first step was to differentiate and end up with a function which is the derivative function. Okay, so we find the derivative at the point given, 1, 1, and the slope was 1. So if that's the slope of the tangent line, then the slope of the normal line must be -1. Okay, so now we've got the slope of the normal line, and so using the slope of the normal line along with the point that's given, we can develop an equation for, this is the equation of the normal line right here. So that's a straight line, it's the normal line, normal to the function. Now I don't know exactly what the graph looks like, but this line obviously crosses our main function at 1, 1, and it's normal at that point. And so this line also crosses the function somewhere else. And your task is to find out where is that somewhere else. So kind of slip back into pre-calc mode, and it's basically a system of equations problem. So here's the equation of the normal line, and the other equation that you're trying to intersect with is the original function, this guy, where is it? This guy up here. Okay, so basically we just did simple substitution. We took the y's that were in the original function, replaced them with this -x+2 there and there. And then it's just a big quadratic, a little bit of algebra. It ends up factoring really nicely, and you get 2 solutions, 3 and 1. But 1 we already knew, of course, because that was the one given to us. So that the 2 spots that this normal line crosses the function are when x equals 1 and when x equals 3. Okay, so the 3 is the new one we were looking for, and so when x equals 3, what's y? Just plug back into this equation, you get y equals -1. So that second point you wanted was x equals 3, y equals -1, and that's the answer. Alright, so enjoy that, and let's see, tomorrow, Tuesday, I do not have time at lunch because I've got a Algebra 1 class at lunchtime. So if you want to try to catch me at break times or other times for questions, feel free. And otherwise, we'll see you on Wednesday. Have a wonderful evening/day tomorrow.